Tonight we're going to talk about securing network services, a little bit about securing web applications, virtualization, and cloud computing. And the securing web applications is a great deal with programming and what it is, and something you need to know about. Unless you're a programmer, you're probably not going to do a lot of securing web applications. Although, you may. That is one. You may get into a situation where you need to test virtualization and cloud computing and the risks associated with those. And that is something the cloud itself. And recently, last Friday, a $10 billion contract by DoD. Don't know, and there's a big conflict now. Should Microsoft have gotten it, or Ch7? Should Microsoft have gotten it, or should Amazon have gotten it? Because Amazon doesn't have the security experience that Amazon does. Amazon's already doing a lot of cloud computing for the CIA, so they have some experience there. And Microsoft, as we all know, is not notorious for its strong security, although it's gotten better and better and better. The web applications and security, and probably try to start the next one. One of the nights this week, we've got to get 2 chapters because we have 4 days and 5 chapters to go, and they get shorter. The other ones, the first 6, I think, were substantially longer than the ones that we have right now. So the securing applications, the module A is securing the principles of securing code, how to implement input validation. And input validation is one of those that we've talked about, and you heard the term SQL injection. The lack of input validation can assist in SQL injection, where we would put in SQL commands, and without the validation or the sanitization, the system would try to run the commands. And that's how we can sometimes, if we don't have the validation or the sanitization, where it just takes those commands out, cause things to happen that shouldn't, and then to prevent common application attacks and hardening applications. So software assurance, secure coding, reduce the application vulnerability, and there's nothing really magic about that statement. And we're going to have some steps to get to secure coding. All that means is that when the program is written, that the author has security in mind. Not that, let me get this thing going, and then maybe we should add a little security to it. A lot of applications are written without security in mind, and a lot of that is because of the pressure that's on the developer to get it done, and get it done now, and then move on to something else. The developers work to make it work, and then look at security. All of the applications have weaknesses, and they're written by humans. And the last bullet there, I think, is pretty significant. 15 to 50 errors per 1,000 lines of code. When you talk about, I think Windows 10's got somewhere around 10 million lines of code in it, so how many errors are there? How many errors are in a Linux system? Because they're about the same size now. How many errors are in any application that we get? So, yep, we're human. We make errors. You've got to go back and check and check and check. And there's some automated devices, and some of those are mentioned here, to help in the determination of, did we make an error? And then the software assurance. When you buy something, and you may not write it yourself, but you'll do a lot of purchasing of software. What software is you going to buy? Generally, it's going to be something that you know about, maybe something that somebody that you know is using. Somebody in the class becomes a network administrator someplace along with you, and you have these meetings, and administrators usually have groups, maybe a LinkedIn, and I don't know, I don't do Facebook, maybe Facebook groups, where they can ask questions and discuss things. And we used to have a group that we hosted at the school that met every month. It was the network administrators in the area, in the Roanoke Valley, get together, talk about things that they've had, share information, networking, and that's what all of this is about, is sharing information. Networking, be it online or in person, in order to share information about these things, that the software is good, is no good, what kind of security features, what kind of development. Those are not always the easiest thing in the world to find out, but user reviews may help you. There's no real, and it says ensure use the security design principles. There's no real standards for security design. There's a couple of models that we'll look at, but the Open Web Application Security Project, OWASP, I'm going to look at their a little bit later, their intentionally insecure web browser. If you have not looked at the front end of the book, there, and I want to open it up and try to go to the front end of the book. That probably won't be here. This too. There are a bunch of virtual machines, and you see the labs throughout the book. These things work pretty well. I downloaded VirtualBox today, and we're going to look at the dojo down here is what's called the WebGoat, which is an intentionally insecure web browser or website, so that you can do all of these things. They've got a lab to do SQL injection. They've got a lab to do a lot of the different things that you talk about. And again, you learn a whole lot more. I learn a whole lot more when I do things, and then I usually have to do it 3 or 4 or 5, 6 times before it makes any sense to me. But these are there. The links are there. You can't go to downloads and see anything, but if you go directly to the link, it'll download a 7-zip file, which is an OVF, I think, that you import into VirtualBox. VirtualBox is free. Download it, install it, and you can run the virtual machines on it. And then you can try out a lot of those things if you think that would help you. The OWASP, the Web Application Security Project, has some standards on their website. NIST and other published standards can be used. The standards tell you how to handle some things. PII, everybody's worried about PII, and I agree. Personally identifiable information, because if you lose your identity, lose control of your identity, there can be some real issues. And I think I told this story. It's not just going out and getting credit cards or those things. This was a case study in a different course, that there was an individual who couldn't get a job, couldn't figure out why she couldn't get a job, was absolutely qualified for everything, and finally did some research and found out that some time ago, whenever ago, her friend Jane Smith got arrested, a DWI or something, and when went to the police station, what's your name? Mary Smith, Mary Jones. So they were using the other person's identity and hiding their own. So it's things other than just, it could be stealing your reputation for these things together. Development operations work together with the stakeholders. These are the images out of the book, the waterfall, the step-by-step requirements, analysis, design. It's a pretty strict formation or format to do development, software development. I've got some other slides that hopefully are a little bit easier to see than this one. The Agile down there, what it's supposed to represent, and we have different versions. And that's kind of what I think we do with most of our applications. We get updates, some of them it seems like every day, but version 1, 0.1, 0.2, 0.3, 0.4 on up to 1.0. Each of them can be released and then checked, updated, released, checked, updated, and released. The waterfall is a longer range, and it's only got one. It's got development, testing, maintenance. Testing, after it's tested, it's released. And that's the step that it takes. In the design and the development, there may be multiple processes in it. So the waterfall method, the analysis, what are the requirements that we're going to have? What programs and applications use? I don't know. I'm not a developer. This is to develop software. This is not the way the software runs. So I don't know what process any of the ones that were developed ran. I don't know. Does that make any sense, Caleb? This is the development program. You're going to go write an application. or even a script. Scripting a little bit easier, and I'm not a good scripter, a little bit easier than programming, obviously, but write a program. What are the requirements of the program? The requirement specification, the project specification and brief. So we're going to have somebody do this thing. The design document, maybe develop a prototype of the application itself. Implementation, iterations, demo, and feedback. The iterations here is, yep, we wrote it, we tried to run it, we want to see what happens, and we fixed it, and we did it again. So the iterations, the quote versions, unquote, which are not true versions, would be at this point here. And then identify defects, resolve the bugs, and then after that, operation and management, the production and the technical support, and then we're going to get the final product would be released. So the waterfall, the bullets from the image, the requirements, function, usability, hardware, and resources. Analysis, we're going to turn the requirements into a model. The design, the framework of how to achieve these goals, kind of the block. Yeah, I don't know. I didn't do ITL, so you guys can help me out here with the ITIL stuff. Design, development, the coding of the modules, testing, the systematic process of finding and removing the bugs, and then maintenance, deploy, and maintain it throughout its lifetime. The Agile program, develop functionality, integrate, test, functionality 2, version 2, integrate, test, functionality 3, integrate, test, demos released, client feedback, make changes, system testing, functionalities complete, and then the next iteration. So we just keep going and going and going. And over here, yes or no, the functionality is complete, no, the next iteration, yes, test and release to the market. So this is the Agile is kind of a continuous. What each does, the waterfall, discipline is enforced. Don't miss any steps. Well-defined phases. There's no flexibility in it. The Agile is iterative and incremental, and each phase is going to be or can be a new version of it. The DevOps practices, and this is just a list of, kind of a list of requirements, checklist sort of thing. Security automation. Continuous integration, baselining. Baselining is a big deal. What baseline security, baselining, what are we going to have, what are we going to do? And then immutable systems and infrastructure as a code. So what are each of these things? Security automation, functional repeatable security tests, which can be applied to each new development with a minimum of human labor. Repeatable, reproducible become key words in networking when you're trying to troubleshoot things. Can you reproduce a problem? The intermittent problems or the random problems are the ones that are really difficult. That, one day something happens, one day something else happens. Maybe we've got a morphing virus or something like that that changes its functionality. One of those that rewrites its code that changes what goes on. Continuous integration, continuously merging code created by different individual developers into a shared whole. So I guess one of the issues that you get into with the various developers, individual developers, not everybody has the same attention to detail. So the integration here, will the parts fit together? That's one of the things, oh, by the way, that made Windows so big. Windows tends to have specialists go develop this portion or that portion or whichever portion, and then they come back together and try to put the whole thing together. So, a lot of times we go into a Windows thing and you got half a dozen ways to do the same thing, and that's because of the way that it's developed with the different areas or different users, different work groups developing different parts of the operating system. Baselining, a good set of security requirements and configurations that are going to support them. Immutable system, deploying them as a monolithic instance as a whole, so that they can be replaced by the next iteration. not modified or upgraded, but replaced in part and whole. And an infrastructure is a code that can provision or configure infrastructure, servers, network appliances, and all of the things that we use. The network appliances, routers, firewalls, switches, to do those things. And provision or configure the infrastructure, provision, actually do the install. Windows did that for us for the provisioning of workstations, where we can boot to the NIC and actually install the operating system on a workstation from across the network. And you can do it hands-off, because you can do all of your configuration, what do you want on it, how you want to configure, what you want activated, what you want turned off. You can do that as a part of the install itself. Program life cycle, the programs themselves, and this is something that I'm sure that you've seen too, all of you ITIL guys, is development, where we create the source code. Source code generally associated with humans, that it's written by humans, but it has to be compiled, converted from source code to machine code, because the machines don't really read the source code. If you've ever installed some Windows versions do that. You get it and you have to go through the compilation process and convert it, the code from one to the other. Linking, components are connected together, and this may be things like DLLs. We may call third-party components in order to do those things. Windows uses DLLs, which are little kind of micro or mini bits of code that are called into the programs to make them operate. The distribution now goes from the developer to the systems, and then installations placed on the system. The load time is storage to memory, and then the runtime is the program being executed. So up at the top here, analysis, user requirements, design the program, code the program, document, test the system, operate and maintain the system. It's kind of the process here that goes with, hopefully goes with the bullets that are below it. Deployment, development, and then the write the code, test the code, accept it, maybe review it, test it, rewrite it, review it, write the code, review, and then once it's accepted, build for production, deploy, monitor, roll back, and then it's done. Rollback is, yes, we have deployed this thing and it's reached its final stage, final functional software, the final functional, and we're going to no longer support it, no longer use it, no longer need it. So development, initially written and compiled, test the software on a physical or a virtual machine. The virtual environment here is kind of a safe way to do this, because as long as we got it isolated, there's no escape, and there's, I guess, easier to get out of it. We can do a snapshot, undo it, go back in time and not have that particular piece of software installed. Whereas on the live system, the physical system, you have to uninstall it and be sure that everything actually got removed from the system itself. Staging, pre-production environment that mirrors the production environment. That would be in either with the physical devices or the virtual devices. And here's where we're going to test the security controls. Security controls tested, and that's the whole theme of this. Test the security controls. Have security in mind when you do these things. Production, used for the final production of the so down here at the bottom, write, test, review, and the test and the review go together. And then we're going to finally accept it, build for production, deploy it, monitor what's going on, because back to the, 15 to 50 errors per 1,000 lines of code to monitor what kind of weaknesses are going to be found. And it may be by us, it may be by others, and hopefully it's going to be by white hats who are going to report it to us so it can be repaired, and then roll back and done. Do it. More coding principles, least privilege. And we've heard that term in regards to individuals, that you want to give users least privilege, the least amount of authority that they need to do their job. You want to do the same thing with the application so that they can't take over the entire machine. And some applications will try to take over and will take over the whole machine. Input validation is input before processing and reject unexpected content. And you can try some, go to a login someplace at the database and, maybe safer on your own machines, but try some SQL injection, see what it works. It's generally just going to be, you can get an error code back. So input validation, do we have the proper kind of input? If it's supposed to be only numbers, then the numbers that are there. The error messages here can be significant. The error messages to the user should be minimal, like it's wrong. Username and password. Username and password combination is incorrect, so you don't get any indication of whether the username is valid or not. You put in the username J Smith and put in a password, and you get an error message back, the password's wrong for the user J Smith. So, guess I got a username, so now all I got to do is figure out the password. So what are we going to do with the input validation and the error messages? Sanitization, delete the dangerous characters or add escape characters. And escape characters are going to keep these things from executing. And this is the sanitization. If we put in the commands for a SQL injection to try to get into the database, and some of those could be something equals something, or 1 equal 1. Well, 1 is going to always equal to 1, and that's going to be true when we do that. So you get a true statement in there, a true match, and then you've now gotten into the system. So those kinds of things need to be validated and sanitized. Cryptography, we've talked about that a lot. Protect the data in the application. Signed applications, encrypted data. The signed applications, again, all that means is that whoever wrote it says that it's good, that it's secure. It doesn't necessarily mean that it is unless we really trust those individuals. Microsoft loading drivers now. The drivers, and you got to go to Microsoft to get them signed. They only load signed drivers. Makes things a little bit safer. And I don't know, maybe I've missed it, but I haven't heard about any except the ransomwares, and that's usually, I don't know, maybe clicking on something that you shouldn't. Haven't heard of any major Windows attacks. I don't know. Is anybody else? You can put in the chat if you have, but no code reds or those kinds of things. It looks like they're getting a little more specific. The people that are trying to take our money from us. In the whaling world or the spear phishing, going after specifics, because a lot of the ransomware lately has been high priced, but they're going after banks and hospitals and governments, people like that. Whereas before they were going after individuals and it was $50 or $60. Now they're thousands of dollars for that. But cryptography to protect these things. Code commentary. Most code, I think probably all code can have comments in it. Why? What were you thinking whenever you wrote this? What's it supposed to do? What's the purpose of this particular one? But there can be vulnerabilities, and I want to look at one here in a second from the WebGoat. Data exposure, session tokens, passwords, PII, protect from untrusted users or processors. We should always protect the personally identifiable information. Passwords should always be protected. And it's an interesting thing. If you've ever looked at the properties of a page and you have cached passwords, you can go back in and change the code of the page from password to text, and it'll show it to you. Now, some places you can just click on it to see the password, what password that you typed in, what one's there. The problem with the cached ones is you may be on a system that has several usernames. You go to the drop down, go to the username, and you got 3 or 4 of them, and all the passwords are cached. Then the ability to get the user's password. Memory management. leave applications vulnerable to memory leaks and attacks. Memory leaks is when an application doesn't give back the memory. When it starts up, the operating system allocates memory to the program, the script, or whatever we're running. When it stops working, it's supposed to release that memory. That doesn't always happen, and that's called a memory leak. It doesn't really leak things out, but it takes memory, leaks to the point that that memory is no longer available. It stays locked. And then error and handling exception, fail-safe error, high detail. The fail-safe error is the one that we're talking about. The user should get minimal, like, the username and password combination is not effective. The administrator should get detailed logging and detailed information about what the errors were when they get those. Input validation, improper characters, character types or formats. When you do an email address, you have to have an @ if you put in a social security number, and hopefully it's going to be an encrypted input where you don't see it, it's going to be 9 characters with dashes, and sometimes they say without the dashes. Unicode characters and characters can be represented in a number of ways, but Unicode characters can be used as an input, and they can cause unexpected things to happen in the inputs themselves. Improper length, buffer overflow, and then improper values, SQL code can cause the issues. A browser code, we can see the browser code or the web page code. I'll just go to one here. I wondered what ESAA is, the one that I borrow. It's here. If we go over here and right click, view page source, you can see what's there, which means that you need to be careful about what you put into these things. So the browser code is all there with the view source. If I had put things that could make it vulnerable in the web page, then it's going to be vulnerable in SQL code, browser code, client side versus server side. The client side is going to be faster, but the good guys and the bad guys, and everybody owns their own browser. So it's a speed versus security. You can modify the browser to do these things. You can use both together. The server-side validation tends to be more secure because it is managed by somebody other than us. Cross-site scripting, and this is just the list out of the book, is never insert untrusted data except in allowed locations. HTML escapes, attribute escapes, Java escapes, that these things can't be executed when they shouldn't. There used to be in the usually the discussion boards, and people don't use those a lot anymore, use Messenger, but used to use discussion boards. You could actually put code into the discussion board that looked like something, an input, a discussion, a post, and it was actually a script that would run when you got to it, or if you click to go into that board. So we have those things. CSS escapes, URL escapes, and then a sanitizing library. All of the cross-site scripting prevention. Cross-site scripting, talked about a little earlier, a way to get you someplace where you don't want to be, shouldn't be. Application, the testing of the applications. We have static analysis, check the code, do a code review. And these are, experts are going to look at those. Dynamic analysis, the system performance, and then the stress testing, some of the automated. We want to stress the application, the code, the website, the whatever we're using to see how it's going to react when it's under stress. Escapes prevent those things from happening. And one of them, let me go back to actually the escapes in, I think I got this right, but I may not. In a web would be where we would put things together in a web browser. We'll put these things together. The ampersigns, the greater than or less than, are usually the starting and the ending of the command. So what we're trying to do with the escapes is preventing the commands from being used where they shouldn't be, except in the code where they're supposed to be used. I don't know if that makes any sense. I don't have good words for that. That's again, I think the closest that I can get with it. Fuzzing, yeah, fuzzing is, yeah, and we're going to get to fuzzing here in a second. Fuzzing is when you just put random inputs into something to see how it's going to react, to see if you can kill. Basically, you're trying to kill the application, because what the hackers are going to do is do something like they're going to try to break it, try to get unpredictable results out of it. And so, yeah, fuzzing would be an application test. It's going to be one of the dynamic, or one of the stress tests. Strenuous conditions. Critical applications, exhaustive tests of all the possible critical errors. What can we do to try to break the software, to try to hack the software, to try to make it non-risks. Third-party code libraries. When you call an application, somebody else wrote one, say, oh, this one looks good, then I don't have to write it. Or even when you copy some of your own code, you may have put too much in, and put too much in, it's going to be, dead code's going to be there, it's going to make it bigger, but it's also going to be perhaps a point of attack. Previously used code copy too much. Change management may introduce vulnerabilities when we do changes, and we kind of talked about that when we do upgrades, changes. We need to go back and look and see if we have done anything to modify the security outlook themselves. And this is the fuzzing here. Automated programs send random inputs. The application protocol and file format application tests the input-output functions. It does all of those things that the hackers may do to us in order to try to compromise the system or to break the system. And a lot of it, sometimes it's just a matter of trying to make it non-functional. Protocol fuzzing uses the protocols improperly. And file format tests the reading and the parsing functions of the files themselves. So fuzzing, automated, test the application, either the inputs for the application itself, the protocols, or will it affect protocols. Deploying the provisioning that the network resources are available and accessible. Server poisoning is setting up a server to host an provisioning, not poisoning. Provisioning, set up a server to host the application. And again, these are nothing really magical, and I'm sure that you have done these things before. Provisioning, create and maintenance of user accounts and attributes. Deprovisioning, freeing up of resources. So provisioning just basically means ensure that the resources are available. Yeah, I've got a piece of hardware, or I've got sufficient memory and disk space on a virtual machine. The host application or the service on it, server provisioning, hey, we install the software. User provisioning, we created user accounts and gave them permissions, the attributes. And deprovisioning, we freed it up. Maybe deprovisioning, we took it away. We didn't need that server anymore. Application hardening, hosts and networks, updates, we want to do that. The account security, and account security may be, what accounts do we have? What accounts have we, who's gone away? Like the instructor that quit, the professor that quit on the first day of classes, didn't need that account anymore. The account security, what kind of permissions do the users have, do the accounts have? And then the security software on the devices themselves, the antiviruses, the firewalls, and those sorts of applications. Secure configuration, secure coding, least privilege, server-side validation. Server-side because once it gets to the user side, it can be testing, human testing, people do it, fuzzing, outside tests, and some places put it up for, if you can hack it, you get $1,000, $10,000, $5,000, a good way to get a lot of people trying to compromise your application when you do those things. Maintenance, audits, patch management, and training. Training being really for all of these things. What we want to talk about for the next little bit is virtual and cloud systems. And we've heard virtual, lots of different virtual words. VPN, virtual private network. VLAN, virtual local area network. Virtual hard drive, virtual storage, virtual computer. So virtual systems, and then cloud services. The cloud services are just the way that we're going to connect to these things. The virtual machines, simply put, is running multiple operating systems or sharing the hardware of a device to multiple operating systems. They could be all Windows, they could be Windows and Linux. We're not going to put Macs in here because they're not part of the virtualization of these things. So lots of technologies, and what it is how the software is used. And a little bit later we're going to talk about the virtualization of taking a lot of the operating system or a lot of the configurations off of the devices and running them centrally. So lots of softwares, the VLANs, the VPNs, the desktops. We had, I don't remember if I told the story, I probably did in Network Plus, but we had at the place where I used to work a lot of really old machines that just barely ran Windows XP. And we got a couple of pretty powerful servers that were assigned to each run a domain controller. And we needed the horsepower, you need the backup database, but we needed the horsepower of probably about a half of a domain controller. They don't do a whole lot. They just, in the morning they get real busy when people get logged on, but it's basically, yep, you're approved. You get logged in. It just says yes or no for your authentication. So what we did with those servers is install the virtualization software in order to create virtual computers on them, put a little Linux client on the weak machines that had a remote desktop capability that they would then connect to a virtual machine running on a powerful server. And at the time they were running Windows 7. So the machines that really had no capability of running Windows 7 were now running Windows 7, but running them remotely. All the processing takes place someplace else. The processing takes place on the server itself. Big servers, lots of processing power. It worked out pretty well, but that is the virtualization of the desktops. You've seen me run a couple of virtual machines in the VirtualBox, the one that you just saw, as well as VMware, the VMware workstation. Achieve the desired function of cost-effective manner. Hardware gets more and more and more powerful. If you look back just a few years ago, and most of you can look back just a few years ago, we didn't have these terabyte hard drives. We didn't have the memory that's running at the speed that it's running at. We didn't have these fast processors. You had memory that, you could put some in. You couldn't put the amount of memory that we put into workstations today in a workstation, maybe in a server, but not in a workstation. So more and more and more resource. So now you're using your computer, and you're probably using processor utilization 2 to 3%. You're using memory, maybe 20% of the memory. Storage, big storage. As you collect things, as I collect things, my storage gets reduced, and then it's the one that you don't really have to delete and throw things away anymore because you've got so much storage. A couple of terabyte drives, and you just I'm not using this one anymore. I'll put it on the USB drive and just store it there, leave it there in case I ever want it again. It's there. Of course, I have no idea where it is when I do that. So to achieve this cost effectiveness, do what a lot of people are doing, either on your own or from a cloud provider, which is to install the software that's required. Windows, the servers give you a hypervisor capability on Windows servers, and depending on which server version that you buy, you get so many installs of other devices, virtual machines on the we can install multiple servers, maybe multiple workstations, or just, I want to do practicing for my security. I want to do practicing for my networking. I want to do practicing for this or that. Or I want to be risky on the internet. I had friends that said, hey, I don't really worry about the internet anymore. I said, why not? He said, I'm using a virtual machine, and if it gets infected, I just delete it and put another one in. That's the other thing you can do. It's just a file. It's easier to back up. We have the snapshot, where if we're going to update it, or if we're going to make some changes to it and we don't know if they're going to work, we take a snapshot of the current configuration, which is fixed in time of what's on that machine at that time. If it doesn't work, we just restore the snapshot, brings it back in time to do those things. Easy to move from one location to the other. And one of those, we talk about redundancies and backups. Pretty easy to back up, to keep a server in standby, ready to go, because we can back it up. We can synchronize one machine to the other, to the virtual machine. We could have multiple virtual machines running on the same piece of hardware. Helps with the heat problem, because we don't have as many servers running. At one time, we had, I don't remember, we probably had, probably about 10 servers running, doing different functions. And we got it down to like three bigger servers running, maybe 4 with the one that we use for the student training. 4 servers running with virtual machines on them. Reduce the heat load. Heat is a real killer on these devices. So platform virtualization, different things we can do. The VMware workstation, I can actually go into it and say, hey, I want to virtualize a computer. I can take the desktop that I have here and I can virtualize. I can use that software and it will take all of the applications and all of the configuration that's on this machine and create a virtual machine of it. So I could make a complete copy of the desktop that I'm using, or any of the machines around. Servers, if you want to virtualize a server, oh, it's too much trouble. The software will create the virtual machine for you, and then you can shut down the physical machine, bring the virtual machine online, and you have a current version. So in the virtual machines, we got, 3 different things here. We've got the host, which is the physical machine that the hypervisor, the software that shares the resources, shares the hardware, runs on it. And they've got type 1 and type 2. Type 1, bare metal. That means that you install a piece of software that what it does for a living is runs virtual machines. It's not a file server. It's not a web server. It's a virtual machine server. So a hypervisor, bare metal. A type 2, a hosted. Type 2 is the virtual box, the VMware player, the Microsoft virtual machine, VM, that run on top of a piece of software. So software that coordinates the VMs, bare metal or hosted. And then we have the virtual machine itself, the device, the set of files that are going to be running an operating system. So it can be accessed out. It's like a physical machine. And I don't know if it makes any sense. Quantaria says that it can't be accessed outside of it, if that makes sense. You're talking about now what, the hypervisor? It can be accessed just like remotely if we configure it like any other machine. It's going to have multiple sets of virtual machines running on it that could be different. It could be different ones. We could have a Linux machine, a Windows machine, a couple of Linux machines, a Windows 10, a Windows 7, a server, whatever number we're up to now, was it 2019, I guess, or anything that we want. We used to run our domain controllers were virtual machines. Our WSUS server, the Windows System Update server, had it on a different device. It was a virtual machine. The DHCP server was a Linux machine. It was a virtual machine. And all those were running on the different physical hardware. Hypervisor allowed them to share, and it separates the machines. They run. When we first started using these things, there were some issues with cross virtual machine infections or attacks, so that one virtual machine is on the same physical device as the other ones might attack one of the other ones. So mostly those problems have been fixed, and they run in a sandbox. And a sandbox just isolates one from the other. At some point, we have to have the host the physical machine. A former student used to work at Rackspace, and Rackspace had an office in Christiansburg, Virginia. They worked there, and Rackspace runs, and they're not the biggest in the world. We got Amazon the biggest, and Microsoft I think is number 2, but they were running somewhere around 63,000 physical servers with the virtual machines running on top of them. Can maintain other copies of them so that, you know, we've got the redundancy. Virtualization allows us to run multiple copies of software on a physical machine and better utilize resources, because, you know, we have, and if you look at it, we go on and on and on and on and on. We had at one time, just to see how many we could get running, I think 90 Windows servers running on one physical device. It was a pretty big device. It had I think 120 gig of memory, 2 quad processors. These virtual machines weren't doing a whole lot, but we allowed them to run there. We used to use virtualization for a lot of courses. So you do a Windows course, you actually had your own device that you could configure. If you messed it up, all we did is delete it and put a new one in. Not a big deal with virtualization when we do those things. So the 3 elements: the host, the virtual machine itself, and the hypervisor. The hypervisor, the software that allows the multiples to be running and to share the hardware resource. Benefits: using different operating systems can share a host without conflict. I think that I had, and you probably didn't see it the other day, when I was running the router and the Windows server, I had a Linux machine running because the router emulator actually wants to GNS3 now wants to use a virtual machine, store all of the information on it. So it was running a Linux machine running and a Windows server machine running simultaneously on a Windows 10 machine. So different operating systems can share the resources without conflicting. Maintenance of one VM is isolated from the others. They are isolated. They're not interlocked together in any sense of the way. Easier to back up and restore and move. We talked about them because they're just files. If we want to back it up, we can copy and paste it. We can use a backup program. And if we want to have, you know, the redundancy, something happens to it, it fails, one gets a virus, we can synchronize, and the virus, we wouldn't want it to synchronize after it got the virus, but we could synchronize on a regular basis based on how much data loss, how much losses we could have. They are easy to move. We can copy and paste them or move them from one location to the other. Gotcha, Adam. Thank you. Easier to change or upgrade hardware on the hosts. Easier to change. If we upgrade the hardware on the host when they're sharing the hardware, it's easier to change these things. If you want to add a hard drive, you just add a hard drive because it's virtual. If you want to add a NIC, you can add a virtual NIC, but you got to have a physical NIC in order to connect it to. The processors, we can usually with the hypervisor, multiple processors. How many processors? How much do we want to give to each device? We could control those kinds of The container virtualization, here is the application 1, application 2. It's the same image that was a little bit earlier, but a little bit more viewable here. This is the computer runs a normal operating system whose kernel can operate as a sort of a hypervisor in itself. The kernel then runs multiple containers. These are applications. We can virtualize applications. Citrix Server has been doing that for a lot of years. It looks like that the application is running on your desktop. Windows does that. Application virtualization as well as machine virtualization for these things. So we can virtualize these to where the shortcut, I guess, would be on the desktop, and then it actually runs an application someplace else. ECPI, the people in Roanoke, will use a Citrix server. All of their applications, their email, their word processing, their spreadsheets and all that were running. Actually, the compute was on a server that was in Virginia Beach. It looked like they were running remotely. And with the speeds that we have now, the connectivity we have now, it's not a real issue doing something like that, running it from one location with the virtualization. Application virtualization, Java does that. Citrix server, what Citrix server basically does is takes over a Windows server, creates new hard drive letters. It uses X for the hard drive instead of C. It basically runs a different interface and creates a remote desktop connection from one to the other. And the remote desktop connection, when we do that, I didn't mean to move that. The remote desktop connection, what I've been doing here, this is a remote desktop connection here. Get rid of that. That runs on a machine that's basically behind me, because when I run my virtualization software on the one that I'm using, it stresses the machine with all of the stuff that I've got going on with it. But we're actually remote desktop. We're actually connected to it. We can have apps. We can have all sorts of things running on that one. And this one, I've got VMware Workstation, and now I've got VirtualBox on it, so I can run it remote desktop and virtual machines on it, look at them, run them on the desktop system. Virtual applications, talked about a little bit. Web apps. The web applications, web apps is, I guess, an upside and a downside. The web apps, everything comes in on 80. We trust 80. We can't block 80, but some hostiles are coming in on the web apps themselves, so that you got to be careful about them. It's just using the web server to run applications. And you probably do that. Maybe you use a web application. You go to your email using a web app instead of a client on your machine. So we have those together. And the virtual applications are just simply, they appear to be on the desktop and they're running on a server. Wine is a virtualization or a conversion software for Linux that allows Windows applications to run. So you can use Wine to run Microsoft Office, for instance. Virtual network devices, and I think we've probably looked at some of these. In here, we're going to have the virtualization environment. We got the virtual server here. Could be a Linux server, a Windows server, a Solaris server. All of these are running on a single physical machine. So this is going to be, we'll call it the host. So it's going to be the physical machine. And each of these are going to be VMs. And they're connected with a virtual switch. So we connect them, and basically what you do is you just tell the software that they're on the same network, and it puts them on the virtual switch. And the virtual switch then is going to connect to a physical switch. What we used to do was we would have our class here, all of the machines connected to a switch, and they were on a network, a 192.168.2.0 network. And then we connected them to a VM, a server VM that was the router. And we could have others, and we may have a couple of classes going here. So we can have multiple IP addresses on the NIC, up to 4, I think. So we could have 4 different networks here with a router, with a virtual machine becoming a virtual router that then connected to the physical network. Got some isolation here with the router. I have routing. I could use a proxy server, all the other things that we've talked about in order to control access to the outside network. But eventually you got to connect to the physical switch somewhere from the virtual switch, from the virtual devices themselves. I think that, well, we looked at some of those, but when we look at the NICs, and let me see, and I've used VirtualBox for all of, but when I look at its settings, and we go to the network here, I can bridge the adapter, not attached. I can NAT it to the network. NAT, we can configure it to an internal network or host-only adapter. The internal network doesn't go off of the virtual machine. It's kind of like the PIPA addresses. Everything within the PIPA address can talk to each other on that particular network segment. All of the virtual machines will be able to talk to each other, but they can't get off of the network. So we can configure these things, and in the system here, how much memory do I want to assign to it? The display, and this is the thing that always kills me with Linux. I've got to get into the Linux machine and configure the display so it takes up the whole screen when I do that. The storage that's available on it, and if we need more and it's running, I'm not going to do that, but I could create more drives if I wanted more drives. Audio may or may not. We looked at network. Serial ports. The machine doesn't have any USB ports. Enable the USB controller on this thing. USB 1.1. So I can use USB on it, share folders, and then the user interface. So we can configure, manage what goes on, what is available on each of the individual virtual machines by controlling how much resources each of them going to have. All of them may not need an equal amount of resource in order to do that. We're going to jump to a different kind of concept here, which is software-defined networking. And what it does, and this is one that they kind of jump into it, and I guess it's going to be there because they jump into it. But we have these different planes, and down here we have a switch. This could be a switch or a router. Different planes that are available in order to manage the different physical devices. And then on here it says the traditional one has a switch. We would connect to it via either a telnet, an SSH, or a console port, and configure each of the devices one at a time. The control plane makes decisions, and it maintains tables, maintains the configuration basically. The other plane that's not shown here that they don't talk about is the management plane. The management plane's us. It's the telnet. It's the way that we get the information to the control plane. The control plane then has all the information that's available for the data plane. The data plane is where the work gets done. That's where the data actually gets sent from one location. And what the one on the right shows there is we take the control plane off of the devices and put them on a controller. And the controller has all of the configuration information for all of the devices. In a routing environment, it would have the routing table. It would then provide the routing table to the device, which would create what's called the switching table, which interfaces it's going to go out to go to particular devices. So centralizing management of the devices themselves. The controller machine where all the information is there and actively talking to the devices is one way to do it. Cisco said they're not going to do it that way. They've got a central controller, but the information still stored on the devices themselves. I think the downside to that is the controller machine goes down. You could have an awful lot of devices running wild, not having updates, maybe not getting the configuration information that they need. Whereas if we're managing them centrally and still storing it on the devices themselves, the controller goes down, we've got time to fix it before we have to actually make changes to the devices. So Software-defined networking take the controlling portion off of the device and put it on a controller. Virtual security benefits, snapshots, easy reversion. We've talked about those, and it is. I don't remember what I was doing. I had a machine that had some software on it, configurations on it that were not coming off easily, that had to come off in order to put an update on it. It was one of those that got an update, put it on, and say, hey, I'm in great shape, and then you get an update and say, it won't install with this other update on it, so now I'm trying to get it off. And I took a snapshot and tried to do the uninstall. It didn't work, so I go back in time. Take a snapshot, do the next attempt to get this update off. Finally worked. Now I don't have to revert, but I still had the snapshot in case I needed it. You can delete them when you're done with them. Sandboxing, isolated from outside hosts. The sandboxing back to the configuration that we're on the local network, or the host network, I think is what they call it. That the hosts on that network with those IP addresses can talk to each other, but they can't talk to anybody else. So we've isolated it. We still have the processing power, but we've isolated it from the network, from networking itself. And when we've isolated it from networking, we've isolated it from attacks. Security control testing, so that we can test all of these things that we talked about earlier. We can run the tests on the machines in the virtual environment. Patch compatibility. Well, we've talked about that a little bit. Patch compatibility is probably not going to be an issue unless you have some proprietary specialized software running. It may break it then. But if you've got, like Windows running, Windows whatever server running, and your company is running Microsoft Office, then the patches are probably not going to break anything. But sometimes you need to check to be sure that you've got all of the prerequisites for a patch. I told you about the guy saw kill an Exchange server because the update came in. Hey, we'll just apply the patch. And after reading the documentation, says this other one's got to be installed before this one, and the other one wasn't installed. And it in fact killed the Exchange server. Never worked again, was never able to recover it. Availability, elasticity. From load balancing and restoration, convenient for these things, and restoration, load balancing, or redundancy, to have something ready to go. And this is one that, yeah, you may want to run on your physical devices, but consider cloud computing and virtualization for the disaster recovery. That you come to work and there's no work there one morning. Fire happened, or some other disaster, gas explosion. But you've been smart and have kept a copy of all of your devices in the cloud somewhere. You can keep going. You can open for business that day, as long as it's just your servers and not all of the workstations go away also. But maybe you've got the workstations virtualized too. And then you just are able to connect to them via a web browser, remote desktop, or something like that. It's convenient for elasticity. I need to expand. The problem with the elasticity is we tend to create an awful lot of virtual machines. Hey, I need to do this other thing. Let's create a VM. We need to do this. Let's create a VM. And you look around, and all of a sudden, instead of having 5, you've got 25. Each of them is, doing a function, but maybe I really don't need all of these VMs. So virtual machine spread is one of the side effects of the convenience that we have for all of these things that we can. Securing them, who's responsible for it? And it's just like a server or a workstation. Who's responsible for a server or a workstation? Anything that you do on the physical machine has absolutely no impact on the virtual machine. If we're running antivirus software on the physical machine, we still got to install the antivirus software on the virtual machine. If we're running a firewall on the physical machine, we still need the firewall on the virtual machine. So who is responsible for it? And then harden the host. And we've heard harden the host, harden the host, harden the host. Do away with all of the processes, all the applications that we don't need to run on it. delete them. Understand single points of failure. What we had done with those machines, we created a great big single point of failure. If the NIC goes down, and that's the easiest thing, the NIC goes down, none of them can communicate because all of the virtual NICs are at some point connected to a physical NIC, be it 1, 2, 3, or 4. So if the NICs go down, you can't communicate with those, either all or a portion of your virtual machine. Power supply failure on the physical server, no standby power supply, you've just lost all of them. So we have created really big single point of failure by using these things. You know, it's a risk reward. Is it worth the risk? And those are the calculations that you have to make. Appropriate security environments, the virtual machines themselves have to be secured. You're actually running an operating system, a Windows or a Linux, or whichever ones that we have virtualized on the systems themselves. Secure virtual network devices. The network devices still have the same vulnerabilities. We have the virtual NIC, we have the virtual switch that's available on the devices. We need to secure the virtual network devices just like we secure the physical network devices. Maintain host resources. Don't over stress the host. I was looking at the one that I'm running VirtualBox on now. I don't have enough resources. I was going to try to start it and VMware at the same time to look at a couple of things, and I want to go back, and we didn't look at the baseline scan last night, and I'll turn the VirtualBox off and turn the the VMware on and look at that. But maintain host resources. Don't overdo it. Don't give away 100% because the operating system needs some resources. Regulatory compliance. Are there rules for virtualization? What can we virtualize? What can't we virtualize? What's legal and what's not legal? And regulatory compliance is going to be based on the industry. The images themselves, the persistent image, we start with a copy and then we update them individually. We used to, when we got ready, we had this golden image. We had a starting image, and we would create images from it. What they actually would do would be to use whatever was available on it, the initial configuration, and then had differential configurations. As somebody changed the name of the machine, then that went on theirs. The base operating system ran off of a single image. A little bit of a method to save on a little bit of storage, because these things can get very, very big when you look at it. They're the same size as a computer. So we have to have really big hard drives to run these things on. A non-persistent, the golden image, the one that we maintain each time the users log on, spin up or spin off a new virtual machine that's based upon it. It's kind of similar to the differential that I was talking about, except instead of doing it at one time, once we created differentials, we couldn't do anything with the golden image or with the base image is what we called it, until all of those differential machines were gone away. If you did, they didn't know where they were. Log in a new VM. When you log in a new VM, it's started based on the golden image with the non-persistent. And that way, the golden image is going to keep all of the virtual machines, the individual ones, up to date, because we then just have to keep the one image up to date and persistent. Live CDs, you probably use those. Linux is great for that, to testing out Linux. You boot to the CD. It loads into memory and everything runs as if it were running off of the hard drive. And then we have private browsing that is available to us in the images. And those are going to be The cloud services themselves, on-demand self-service. If you go to Rackspace, their website lists the platforms, the things that we can get at Amazon, the Microsoft. If we want to go in and get a Microsoft Azure, an Exchange, a Hyper-V, Office 365, SQL Server, OpenStack, Oracle, the different platforms that are available, the different resources that are available, the services that are available. But the on-demand self-service login, I don't have an account, I can buy now. Fanatical support, Office 365, Rackspace email, buy now, on demand. Log in. I can log in and Rackspace email, customer support portal, whatever we're going to do in here. If I had an account, a platform, let's say that we could go down here and try our single tenant dedicated exchange solution. Eventually, having an account, I could go in here and specify what I wanted on that. It would build a machine for me, send me an email, say, hey, your virtual machine is ready, or your virtual infrastructure is ready, or your whatever you ordered is ready. So on-demand self-service. On-demand, I can log on and change it. I can add or I can take away from those. And the on-demand example might be that you're a retailer and Black Friday's coming up and you need more compute power. So you go to your provider and order more compute power, order more storage space, order more networking in order to sell your products. On-demand self-service, I can just log on and do that, pay for it with a credit card. Broad network access, web access. I got there just now through a web interface. We could do remote desktop. You could get there with your phone. You could get there with your tablet. Resource pooling. The resources on the servers are pooled, and then the rapid elasticity, the ability to expand what we need. And in a measured service, they've got to have some way to bill us. So they're going to measure. It's time. Let's go ahead and finish up the virtualization for these things. The cloud models themselves, the different things that we can do on the cloud. And we talked about having a computer. We could have an entire network. You could go to Rackspace or to Amazon Web Services or Microsoft, and you could buy your entire network. You could have everything there. As long as you had good network internet connectivity, you could run everything from the lightweight workstations, which don't have anything on them really except a web browser and a remote desktop keyboard and a mouse and a remote desktop and RDP connectivity for those things. Platform as a service, access a computing platform that can be used to develop and host applications, and then infrastructure, the computing and network resources themselves, a little bit of everything. This slide maybe, I don't know, hopefully it's a little bit more of what we're talking about. Software as a service, the operating environment, largely irrelevant. The operating system, we don't care. Fully functional applications are provided, and then we've got CRM, ERP, email. Gmail would be an example of software as a service. Outlook.com would be software as a service. Platform as a service, the operating environment is included. Windows, .NET, Linux applications of choice are deployed on the systems. So platform as a service has a infrastructure as a service. The virtual platform on which required operating environment and application is deployed includes storage as service offerings. It is the entire network, the whole infrastructure, all of the devices and storage and everything that we need to basically run a network. And down at the bottom there, the cloud computing services, the thing that's been added is who uses it. Software as a service, business users. Email, automation, CRM, website testing, wiki, blog, virtual desktop are all things that are available as software as a service. Why use it? To complete business tasks. Platform as a service, developers and deployers are going to be using these. Service and application testing, development, integration, and deployment can create or deploy applications and services for the users. And the infrastructure as a service, system managers are going to be using it. Virtual machines, operating system, message queues, networks, storage, CPU, memory, backup services are all going to be part of the infrastructure. Create platforms for service and application testing, development, integration, and deployment. Or probably what could go in there, run my small business. The cloud deployment models, there are 4 of them. The hybrid is kind of recent in these things, but the private cloud manufacturing organization has its own private cloud. The private clouds are a single entity, a single organization is going to be on a private cloud, and they're frequently hosted on premises. They may be hosted someplace, and I think if you look at the rack space, it said that they'll host your private cloud. Private cloud, only you own it. Only your company has resources on that private cloud. Nobody else is on the machines with you. A public cloud shares the cloud with the general public. You don't know who's there with you. It could be, the church next door, or it could be the hacker on the other side. A public cloud is just that public. It's shared with everybody. A hybrid combination of cloud deployments, and a lot of deployments could be private and public put together. That some of it is private, but then the public cloud is okay for some of the other resources that are available. The community cloud, the organization shares it with organizations of similar interest. Boy Scout troops would all be on the same cloud. So the 4 different cloud deployment models that are available today, those may change, obviously, and a lot of that does change. So cloud security, all of these devices are still going to be subject to network attacks, and in fact may be a little bit more susceptible to network attacks, because we have to access them across the internet if we're on a public cloud. Private cloud, maybe not. We may be able to do it internally. But attacks on the connectivity between us and the resource can be an issue with these things. Off-site requires secure communications from one to the other if we use the public cloud, and probably the community cloud because we're sharing it with others, or the hybrid cloud. Control is given to another entity. Somebody else now has access to all of your networking. The other ones down here vary. Attacks on the cloud service may affect many customers. One of the other things that's probably on one of the other slides is you don't know where your stuff is. It's in a data center. It's in a data center for that company. They're probably having redundant systems running. They could be stored in the U.S. They could be stored in Hong Kong. They could be stored in a place where the privacy policies are radically different. The laws are radically different than the U.S. So you only have protections of the that are effective in the country where the data actually resides. There can be some issues. Some of the providers, actually a number of the providers, are actually starting now to build data centers in Switzerland because they figured the neutrality there, that they can keep the data. One of the issues with the cloud security is you don't really know where. Legal implications. This is maybe shared or moved between data centers. There's no guarantee that it's going to be stored in the U.S. There's no guarantee that it's not going to be someplace where one of the countries can just come in and look at the information. Data sovereignty or residency, and this is the don't know where it's physically located. And some countries, a number of countries, actually have weak privacy laws. The Europeans probably have stronger privacy laws. We run into issues with some of the things that our innovators do. Europeans get knocked out. That's the reason that Microsoft lost a lawsuit about the browsers, and it was because of the EU.